All right, so the one thing that our big goal and how this relates to geometry, because I know you've been thinking, oh no, this is algebra again. Well, what we're going to do is relate slope to parallel and perpendicular lines. So we're going to see how slope relates to these. Now your instinct probably, you already have an idea about parallel lines based on our warm-up. And we said, oh look, these lines here are parallel, so what about the slopes? What can we say? Well, what we're going to actually do is calculate and then make a conjecture. So that's what this conclusion is down here. After we calculate the slope of these two lines, which are parallel, we're going to calculate them and then make a conjecture. And then over here, these two lines are perpendicular. We're going to calculate them and see how they relate to each other. All right, so I'll walk you through the first part here. I'll find one slope, you find the other. Notice here that it actually tells us M1. M1. Now, by the way, M1 simply means my first slope. That's all it means. It's just a way of using the letter M more than once. So notice over here I have M2. So it just means the slope of my second line. All right. So let's go ahead and attack. I'll do the top line and then you'll go work through the bottom. In this case, we can either do subtractions with the numbers or we can do our counting. Since I have a graph, I'll do my counting. So when I start at this point and I go to this point, I go up 1 and right 1, 2, 3, 4. So my slope there is up 1, right 4, and that's it. I don't have to do anything further. All right, so as we do the counting, again, remember where to start. I'm starting right here and I'm going to this nice point. So I go up 1 and then right 1, 2, 3, and 4. So down here, my second slope is 1/4, and we say, ah! What do we notice? What do we notice? That we have exactly the same. So what can you conclude about parallel lines? The slopes of parallel lines are the same. Good. The reason why we don't say congruent is because slope is a number, not a shape. So there we go. Slopes of parallel lines are the same. Now let's do the same thing for perpendicular. I'm going to find the slope of M1, and you, please find the slope of M2. So as I do this, I notice that my slope is actually negative because it goes down as I read. So starting at this point and going to this point, how much down and how much right do I go? So my slope of the first line starts here and goes down 1. So down 1 and right 1, 2, 3, 4, 5, 6. But notice I didn't put the down part yet, so that's where the negative 1/6 comes in. Please, so as we count the slope on this one, to get from this leftmost slope, I go 1, 2, 3, 4, 5, and 6, so up 6, and right 1. So the slope here is positive 6 over 1, and we reduce that to 6. However, the fraction is going to help me make a conclusion. How does this negative 1/6 relate to this 6 over 1? What two changes do you make from here to get to there? What two changes? How do we state the change here? This sign changes to positive, and this fraction reciprocates. So how do we say that? We say the slopes of perpendicular lines are opposite reciprocals. Reciprocal is a funny spelled word, so please check your work there. So that's one way to say it. All you do is change the sign and flip the fraction. Make sure it has to be a fraction first to do that. All right, another way to consider it looks like this, is to say that when you multiply the two slopes together, you get a negative 1. That's just an alternate way of saying it. However, for our purposes, opposite reciprocal is probably going to be the best way to interpret. So here determine if the lines are parallel, perpendicular, or neither. So we know the lines are parallel if the two slopes are the same. And then we know the lines are perpendicular if we get opposite reciprocal. So I will just write it like that. And every other option is going to be neither. Every other option will be neither. All right, so please take a moment and attack, kill, destroy number 1 with your neighbor. Good, so the first slope there reduces to 1/2. And what about the second one? And that reduces to -2. So now the interpretation part. Are these the same, opposite reciprocal, or neither? And the answer is they're opposite reciprocal. So we now say these two lines are perpendicular. So in this next one, notice the slopes are pretty darn close because the first one is -5/2, the next one is -4/2. But close means close. That's it. They're almost parallel. So the answer here would be neither. There's nothing special about the relationship between these two lines, except that soon they will intersect at some point in time. 6. For the first one, 2/6 for the second. They both reduce to 1/3. Clean that up. 1/3. Notice the instructions do not say you have to reduce necessarily. All it's saying is determine if the lines are parallel. And since you got the 2/6 both times, that's enough information to prove the lines are parallel. So we can just use the simple here saying those are parallel. The last thing we want to do today is apply this and start applying this to some future concepts. We are going to look at a quadrilateral. Remember what a quadrilateral means? Quad generally means 4, and lateral means sides. So this is an object with 4 sides. So when we say quadrilateral, do not say, oh, it's got to be a square. It could be a trapezoid. It could be something that looks like a kite or a diamond. And when we say diamond, often we mean what's actually a rhombus. So quadrilateral simply means 4 sides. It doesn't have to be a square or a rectangle. Those are very special types. Okay, so what we're going to do is use slopes to determine whether the opposite sides of this quadrilateral, WX, Y, Z, if they are parallel or not. So let's go ahead and plot these. You don't always have to plot it, but I'm going to plot it in this case just to give us a visual representation. All right, so I'm going to plot each one of these. W is at -1, -1, so it's right there. And I'm going to label that with a W. X is -3, +1. So I'm going to place that right here, like so. And then my Y is -2, +4, which is up here. And let me go ahead and make sure to label these points. And then the last one, Z, is 2, +3. Oh, thank you. X should be the other one there. So let's see, X. Great. All right, good. Thanks for seeing all those mistakes. So let's go ahead and make those changes. All right, so make those changes here. Now, if I were to sketch it, what would your hypothesis be? Are any of these look parallel to you or perpendicular or anything? No, if I were to sketch, I would say, oh, pretty much nothing's parallel. However, what we have to do is let's demonstrate that's true. Let's demonstrate that's true. My instinct, it looks like they're not parallel. So all I have to do is show it. And when it says opposite sides, it means this side over here compared to that side over here, because those are opposite of each other. And this XY and this WZ are opposites. So I'm going to do WZ or WX there, and I'm going to do the YZ. So I'm going to see if those being my opposites according to my diagram, I'm going to check check those. So the slope of Wx, slope, is equal to this. Remember, I do my subtraction there. -1 minus a -1, all over -3 minus a -1. So notice I get 0. Now to compare it to yz, the slope of yz. Now we already think, according to the diagram, that they're not going to be the same. So that's my expectation, so I'm just going to prove it now. All right, so yz, so 3 minus 4 here. And then 2 minus a -2, which is the same as 2 plus 2. And so my result is -1 over 4. And clearly we see that these are not parallel. So that's the first pair. Let's find the slopes of xy, xy, and wz. So xy would be 4, sorry, wrong place. Sorry, that's not right. So I have to go from this 4 to the -1 and this -2 to the -3. So 4 minus a -1, so that's 4 plus 1. And then the -2 to the -3, so -2 plus 3. So that's 5 over 1. And now for the green, I go 3 to the -1, so 3 plus 1, because I double negative is positive. And then we go 2 to the -1. So 2 plus 1, because 2 minus a -1. So this is 4 over 3. So these two clearly are not parallel.